Alright, hi, this is module or unit 6, trigonometric functions, and today we're going to be talking about lesson 1, which goes along with homework 1, and we're going to be dealing with basic trig identities in order to solve trig problems. So the identities that we're working with today, some are ones that we're familiar with and some are going to be brand new. So we're going to be working with the quotient identities. So even though we talked about tangent being equal to y over x, we want to formalize that definition. Tangent of theta is always equal to sine theta over cosine theta. And then since cotangent is the reciprocal of tangent, if we flip those around, the cotangent is going to be equal to cosine over sine. And then we have our 6 reciprocal identities that have to do with the definition of cosecant and secant and cotangent, and just the fact that they are all reciprocals. So sine and cosecant are reciprocals, and that works vice versa. Secant and cosine are reciprocals, and cotangent and tangent are reciprocals. So we're going to use those in order to find values of trig functions. So in example number 1, if we're given the secant and we're being asked for the cosine, well, secant and cosine are reciprocals of one another, so we would say since the secant of theta is 1 over the cosine, or the cosine is 1 over the secant, if our cosine of theta, if our secant of theta is negative radical 30 over 3, then our cosine of theta will be the reciprocal. So I would put a negative, I'm going to put my 3 over root 30, and then I'm going to rationalize the denominator. So multiply by root 30 over root 30. I get negative 3 root 30 over 30, and then I need to go ahead, if there's ever a fraction that can be reduced, I want to go ahead and reduce. So 3 goes into 3 1 time, and 3 goes into 30 10 times. So that makes my final answer negative root 30 over 10. Next, I've got a tangent, a cosine, and I'm looking for the sine. So I'm going to use the fact that tangent is always equal to, tangent of x equals sine of x divided by the cosine of x. And then I'm going to substitute what I know and solve for what I am looking for. So I'm looking for the sine, and I'm given the tangent and the cosine, so I'm just going to substitute. So my tangent is root 2 over 4. My sine is unknown, and my cosine is negative 2 root 2 over 3. And so I'm going to go ahead and use the rules of algebra, and that's what we're doing a lot in this chapter, is we're combining trig and algebra. So we're using the rules of algebra to solve for the missing item. So whenever I divide by something, if I want to undo it and isolate my variable, I'm going to multiply by it. So I'm going to go times negative 2 radical 2 over 3 on both sides. And those guys are going to cancel. And so I'm going to come up here while I finish this out. So I'm going to do in the numerator, negative 2 times radical 2 times radical 2 is going to be negative 4. 3 times 4 is 12. And so I'm just going to reduce that. Negative 1/3 is the sine of x. Now my instinct is to go ahead and do inverse sine and figure out what the angle is and figure out what x is. But I'm not asked for all that. I'm only asked for the sine of x, so once I have that I can stop. Next problem, we've got cosecant of beta equals 7/3 and cotangent of beta equals negative 2 radical 10 over 3, and I am looking for the secant. So Secant, I need to just sort of, while you're in the beginning of being able to do this, you need to just analyze, what is the secant? Secant is 1 over cosine. What is the cosecant? Well, that's 1 over the sine. And the cotangent, you can either, we kind of want to think about all the different ways we can think about cotangent. I can think about 1 over tangent, but I can also think about cotangent is really cosine over sine. So using what I have here, I'm going to just start out by flipping this 7/3 and saying, all right, I know my sine of beta is 3/7. And I am going to go ahead and write an equation where I set the cotangent equal to cosine over sine, and then that's going to help me know what cosine is, and then I'll be able to find my secant. So I'll do, this is my formula right here, and then I'll start plugging stuff in. So cosine is unknown, the sine is 3/7, and the cotangent is this expression, -2 radical 10 over 3. So to isolate cosine, I'm going to multiply both sides by 3/7. So as I'm multiplying here, I can cancel out my 3's, so I get that the cosine of beta equals -2 radical 10 over 7. Now, I don't want the cosine, I want the secant. So I have to go in and flip that and then rationalize it. So I've got my secant as 7 over -2 radical 10, and to get it rationalized, I'm going to multiply by radical 10 over radical 10. So I get my secant equals 7 radical 10 over -2 times root 10 times root 10. So that's -20. And if that reduced at all, I would reduce it, but it doesn't. Next example, I think we're going to start getting into our Pythagorean identities here. So before we get too far into this, I want to talk about where these come from. So I want you to think about in the unit circle in quadrant 1. So my first initial triangle is that 30, 60, 90 that has the 30 degrees in it. And we know our side length, we know our x, and we know our y, and we know our r. So in a right triangle, we have x squared plus y squared equals r squared. That's in a general right triangle. But in the unit circle, we know that all of our x values are really the same as our cosine. So I'm going to substitute cosine there for my x value. And then we know that the y values are sine. And we know that our radius inside of the unit circle is always equal to 1. So I'm using the Pythagorean theorem, the unit circle, and my trig functions to arrive at my first trig identity. These are called the Pythagorean identities for that reason. And I personally have an issue with memorizing all 3 Pythagorean identities. So I just want to show you where the other 2 come from. And I'm going to do that in this white space out here to the side. So if I start with cosine squared plus sine squared equals 1, if I go through that equation, and I can divide, as long as I divide the same on both sides, I can divide by anything I want. So if I go through and I divide every single thing by cosine squared, I get cosine over cosine, which is 1. And then sine squared over cosine squared is the same thing as tangent squared. And then 1 over cosine squared is the same as secant squared. So that is where one of our Pythagorean identities comes from. And then the other one, if I start back again with my original Pythagorean identity, and this time I divide everything by sine squared. So that's legal, because as long as you divide on both sides. So now I've got cosine squared over sine squared equals cotangent squared, plus 1 equals cosecant squared. So they are all derived from each other. So now I want to use that to solve problem number 4. And if I have cosine and tangent are given, or I'm sorry, I'm trying to find cosine and tangent, and I'm given that the sine is negative 1/3 and the cotangent is less than 0. So I know, because of all students take calculus, I know that sine and cotangent are both negative here in quadrant 4. So I'm sort of picturing my angle down in quadrant 4. So there's an angle in quadrant 4, and there's theta, and there's, if I drop a perpendicular, so my sine of that angle, I'm labeling the sides negative 1 and 3, so that's opposite over hypotenuse. I put the negative with the opposite, and the hypotenuse always has to be positive. So that's just a picture of what that angle looks like. I can figure this stuff out without a picture, so my apologies if I've confused you. If I just write out my Pythagorean identity, sine squared plus cosine squared equals 1, I could substitute what I know. I know the sine, and so when I square that, that'll be 1/9, and if I subtract it from both sides, I get 8/9. And so then to find the cosine, I just square root both sides. So the cosine of that theta is square root of 8 is 2 radical 2 over 3. Then I can go ahead and do my tangent. So to find the tangent, I'm going to do sine over cosine. So tangent of theta is sine over cosine. So I'm going to divide negative 1/3 divided by 2 root 2 over 3. And if I keep switch flip, I am going to end up with my tangent is negative 1 over 2 root 2. So I multiply both top and bottom by root 2, and I get negative root 2 over 4. So that's my final answer for the tangent. Okay, so for question number 5, I want to find the tangent and the sine. I'm given the secant, and I know that the sine is positive. So actually the secant and the sine are both positive. The only place that cosine and sine are both positive is quadrant 1. Let me get a different color here. So I would go ahead, if I know the secant is 6/5, then I know the cosine is 5/6. Because that's a reciprocal. And so I'm trying to find sine and the tangent. So I'm going to use sine squared plus cosine squared, or 5/6 squared, equals 1. And so that is 25/36. So where is my sine? Sine squared of x plus 25/36. So I'm going to subtract 25/36 from 1, and I get 11/36. And so I square root both sides, and I get my sine is equal to root 11/6. So then I need to find the tangent, and I'm going to do sine over cosine. Which is root 11/6 divided by 5/6. So keep switch flip. Square root 11/6 times 6/5. Boom, boom. Get root 11/5. Alright, so these cofunction identities, we are not going to work with them very much at all. All you need to know is that they exist. Okay, and lots of you already pointed out sine and cosine are related because they're simply a phase shift. If you take cosine and you move it to the right, you're going to end up with a sine wave. Excuse me. So basically, and then the rest of you have noticed on these even odd identities, you've been able to notice, like across the unit circle, where are the trig functions equal to each other. And so these are just formalized definitions of the behavior of the unit circle and when you look at a sine wave and if it's shifted. So if we need one of those, we'll have our formula sheet and we will look it up. So that is the end of lesson 1, and hopefully you have enough information to work on your homework at this point. Thanks for watching.